So I just want to mention before we start the performance testing and stuff like that. The thing I mentioned, so a day or two has passed since recording last time, and I have had some issues with Windows Update. On every reboot, it would say like updates are underway. Please keep your computer on, and I couldn't update drivers for the GPU or anything because it could sense that Windows Update is sort of due on installing the updates on a restart, so it would prompt me to restart, and it would just go on and on all the time. But I managed to solve it, and it solved itself basically after a while, leaving the PC on, and then suddenly Windows Update displayed some previously shown updates that maybe failed, and this time they didn't fail, and it could all go well. But as a result, I was able to update the GPU driver, and previously on scenes like this, where I have a lot of bright area, white background, and if you remember, I said that the sort of almost like the brightness or backlight, of course this is an OLED, so there is no backlight, but the brightness sort of flickered. But now after installing the update for the GPU driver, it has stopped, so the image is now a lot more stable. And also it seems better on the PWM stuff, maybe. The image is a lot more calm, I would say. And the flickering stuff is gone, as far as I can see at the moment. So I'm just checking the list here of installed apps, and we have a lot of bloat. But we have some Acer stuff. We should see what that is. It could be good to know if you plan on buying one of these laptops. But before removing anything, I want to compare the sort of impact. So I have installed I have installed 3DMark and PCMark over here. So we will run those, and maybe we'll check AIDA64 as well, just to see where this laptop places itself. And I think we will do a few performance tests, like out of the box with the bloat, with the McAfee and all the Acer stuff, and then we'll debloat at least some of it, like the McAfee, and maybe even set Windows to some mode that will not use as much RAM, maybe, and see how that affects performance. And then we will run it at high performance mode, balanced, I think, and then maybe on battery as well, and see. So that's the current plan. I think we should basically get to it and start do some tests. But yeah, it hasn't been the smoothest sort of out of the box install. I had some issues. So there's the bloat, there's the Windows Update issue. I updated the BIOS. Maybe we should check what the BIOS looks like as well, and what settings are set. So yeah, I think that is a good idea. And we are in BIOS. This is what it looks like. So we have a few menus over here, and then we have some information and settings here. And we can see that have some system temperature. I don't know if that's CPU, but 38 currently in BIOS, and we can then go through the options. It basically shows some temperatures and stuff. Firmware version, so I updated it. It was 1.05, now it's 1.09, the BIOS. So it is the newest as of today, Saturday, September 6th, 2025. If we go to main, we can see system time, system date, stuff like that. Network boot and F12 boot menu. I like that. And then there are a few things like a keyboard backlight timeout, fast boot. Yeah, I don't like fast boot, so we turn that off. So all the settings were default here before I started to change them. Advanced isn't too advanced really, because well, there's storage configuration and stuff like that, but not so much more. There's no like overclocking or that kind of menu, like setting memory timings or. But I suppose a laptop is a laptop and it's Acer and stuff. So, and then yeah, that's basically it. So not much in the BIOS, but we do get some resolution and temperature display here, and there's some information here. We can at least toggle some keyboard settings with the backlight and stuff. Right. So now we have seen that. Let's exit this. Save and exit. Right. So what we're looking at is well, these are two reports from AIDA64. Now on the left we have the balanced power plan, and on the right we have the high performance power plan. And maybe I should increase screen brightness. I don't know if that does much, but maybe we have a bit less PWM modulation, maybe. Anyway, so I still have all the bloat with the McAfee and stuff. We will start there to get the sort of out of the box experience that most users will have when they buy this laptop, or at least when they use it. And I have also connected a power meter to the power brick, but of course we have the battery as a buffer and stuff, but still in balanced power plan mode with this display like 3 steps from maximum brightness, I saw about 5 to 10 watts of power use. And on high in such an idle state with the reports just open in Edge in this case, and having a couple of apps in the background running, and of course we have McAfee and stuff running in the background as well. That's pretty good, I think. I think that 5 to 10 watts, it was mostly idling at 5 and jumping to 7, 10 sometimes, and back to 5. 5 watts with the display on. Of course we are in sort of the dark mode here, so many pixels here are not particularly active, let's say. And on an OLED, of course, if you have the darker the display image, the more black you have in it, the less power it will draw. But 5 watts for the entire system with the display just idling at 5 watts and jumping a bit up to 10 now and then is pretty good, I must say. And that is in balanced mode, and in high performance mode I saw between 8 and 12 watts instead. So it's not a huge difference, but there it is. And anyway, I have run the AIDA64 benchmarks, and we have a few parameters: memory read, write, copy, latency. We have some CPU benchmarks. So I won't go into much detail, because a long story short, the difference between balanced mode and high performance mode, with all the bloat still on the PC, is pretty much within variance, I would say, except for two specific benchmarks. So anyway, we'll come to that, but let's just see. I like AIDA64 because we get some references to other types of systems. And regarding memory read, well, this is an 8-core Ultra 5 226V in this laptop, and it's 4 performance cores and 4 efficiency cores. And this is running DDR5 with latency at 40, but still it beats many sort of compute heavy systems like the Threadripper ones, almost in the same ballpark. So we have 84,445 megabytes per second on this laptop, and 84,515 megabytes per second on the 32-core Ryzen Threadripper 3970X on the TRX 40 platform, with a quad-channel DDR4 3200 at latency 16. So it's not bad in terms of raw sort of read performance. And on the right here, we can see in the high performance mode we actually lost a bit of performance at 84,211 megabytes per second. And pretty much so going through this memory write, you know, this pattern will repeat itself. So we have 111,504 megabytes per second write in balanced mode, and 111,461 megabytes per second in high performance mode. Once again, a bit lower in high performance mode, but I think it might be variance. And this repeats itself in memory copy and well, memory latency. So the latency is nothing to, you know, write home about, but it's 94 nanoseconds in balanced mode, and it's actually 95.5 nanoseconds in high performance mode. And if we continue here, let's see here, we have the Checkmate benchmark, which I think is a chess related benchmark, and we land on 2377, and in high performance mode we land on 2383. So a little bit more in high performance mode, but a few points when we're talking about the thousands here. So this repeats itself up until the two very last benchmarks. So let me scroll to those. Yeah, so FP33, that's 32-bit precision floating point ray tracing, and we have let's scroll down on the high performance mode. Find the right spot. Yes, here we have it. So let's find our value here and our value over here. So 11,877 versus 12,024. That's pretty much the largest difference. Even though it's still small, it's like, well, 200 points out of almost 12,000. So it's not a whole lot. A couple of percentage points. But then on FP64, 5903 kilorays per second, and versus high performance mode. Which is 6,560 kilorays per second. So here we can see like 550 points or so. Oh, 650 points or so difference. And so considering the only difference was high performance mode, 650 points out of 6,000, that's just above 10% improvement. So we managed to beat. So on the left here, in the balanced mode, we're behind the 16-core Xeon E5 2670, and here we have passed it and the Core i7 8700, which isn't a very fast CPU nowadays, but I suppose that an entry-level sort of laptop AI PC, even though the price is, of course, yeah. But anyway, you know where I'm going with this. But this is pretty much the only place where I saw a meaningful difference in the high performance mode. So how does the laptop perform then, according to AIDA64, with the bloat on? And if we just check the high performance mode, or maybe the balanced mode, I suppose it depends on what you're doing. But if you're gaming, I suppose you will turn on the high performance mode. But if you just, I don't know. But the points are pretty much the same, except for ray tracing. So the memory stuff isn't too exciting, maybe. It doesn't translate into an application or a benchmark of some application. But if we check the checkmate, for instance, then we're between, right in between a Core i7 8700K once again, and a Core i7 7800X. So somewhere around there. Let's check another one. PhotoWorks, that's probably photo editing, if I'm not mistaken, and we're pretty high up here actually in the list. So we're between a 13900K, actually beating the 13900K, and well, 1,300 points away from a 32-core Ryzen 3970X, which is a pretty strong performance value for this PC. Of course, this all depends on the fact that the memory should be enough memory. So it will be interesting to see when we debloat the PC how much, if anything, we actually gain or not. We also have the test zlib, which is compression. I think maybe decompression as well. Perhaps compression. Not a particularly strong contender here. Below the 8700K, but pretty much in the same ballpark. And yeah, closer to the 8700K than the 7800K X at least. But still, for a PC from the year of 2025, yeah. But okay, so it's not a AES. We have compression, and also in the compression tests, well, it beat the 4-core Ryzen 5 2400G, which isn't a particularly fast CPU nowadays. It beat it, but not by a whole lot. So maybe you don't do a lot of compressing hundreds of gigabytes of data on this machine. So here we have hashing, I think, and then also in the same ballpark as the 8700K. So basically this is an 8700K but in a laptop configuration with low power. So that's of course good that you get that performance. The 8700K drew a lot more power, of course, than this one does, I suppose. So yeah. Once again, this one floating point operations, so not too bad, but we beat the 8700K, but not the 7800K or the 11900K. So that's pretty much where we're at. So yeah, I won't go through all these numbers now, but now understand a bit where this PC sort of is. But of course, this can all change depending on the RAM, I think, how much RAM is available. And I think we'll see those effects better maybe in the PCMark 10 testing. But before we do that, let's actually check the power draw. So we have the Acer Sense something. Acer Sense, yes. That's an application I maybe will leave here, so maybe users will leave it. You get your updates for your PC listed over here, so there are no updates. It's up to date. You can switch between silent, normal, and performance mode. So the balanced was normal, and the performance is performance. And in the control panel, power options, we have the Acer one chosen. I suppose it was default, and maybe most users will remain on that. And I suppose in theory it should work the best with sort of in synergy with the Acer Sense. Ooh, and once again I'm seeing a little bit of flicker on the screen with the brightness. It was gone yesterday when I updated the GPU driver, but now it's back a bit. I don't know why and what happened, but why it does that. But okay, let's see here if we increase this to max. Yeah, there's still a bit, but I don't know. Maybe we'll figure that out. So we're in high performance mode, and yeah, let's check the performance burn-in test, system stability test. This is a trial version here, but We will not stress well, we can stress GPUs. Okay, so the timeout detection and recovery delay value is configured too low. It may cause the video driver to be reset while running the AIDA64 system. So they want to fix this issue for you now. Okay, you need to restart Windows. Okay, no. We'll not stress the GPU now. We'll just stress memory, cache, FPU, CPU, and yeah, let's start this and see what kind of temperatures we get. And also the power draw. I will go check on the power draw now. Right, a little bit of time has passed, and we can see all the temperatures here. On the bottom part here we have 28 degrees. That's the Kingston SSD. So the temperature of it also rises because everything inside rises in temperature. But then we have 72, 71, 66, 69 maybe, yeah. So the cores seem to have stabilized a bit at around 71, 72 down to 66, 68 degrees. But we can check the stats over here. So CPU overall is 71, maximum 72. Hottest cores, 2 of them reached 72 at the maximum. But the average is about 64 degrees on the hottest core. And the CPU package 65.8, average 65.9. So yeah, that's where we're at. And I checked the power meter, and it showed 45 watts pretty steadily. But this is without the GPU running, so we'll have to do that test. And we are in high performance mode as well right now. So we're not throttling, which is good. The noise is clearly audible, but it's not whiny. Let me take the microphone. Oh, that is very close to the air outlet. The core frequencies, so we are at about 3.5 gigahertz. A couple of cores are at 3.4. We'll zoom back in a bit. But it varies a bit, but between 3400 and 3500 at full core load, all core load, in high performance mode. Now let's stop this test, and we will switch back to normal mode. And let's go again. Once again without the GPU currently. And we shall see if there's a difference. I will go check on the power meter, so I'll be right back. Yeah, I saw pretty much the same numbers, the same figures, 44, 45 watts in balanced mode as well. So I don't know if that may explain why we got very similar values in the benchmarks as well. This has only been running for 2 minutes, so too early to conclude anything, but let's look at the stats. Yeah, let me just move this a bit. So, however, we can see that some cores are lowering clocks, 3100, 3200. I didn't see that on the high performance mode. Some cores are at 35. I suppose we have 4 efficiency cores and we have 4 performance cores. So the question is which are which, but some cores are definitely running slower. Let's actually change this on the fly to silent. Now, let's see if anything happens. Yeah, 3300 and 2900, 2600. And the fan is spinning down a bit. So the cores are cooler. Yeah, definitely there is an impact here. But yeah, we can see 92% RAM usage. I suppose it's reading and writing to RAM, so that's normal. But yeah, we can see there is a difference in the clocks, at least. It does seem to work. Sort of. Let's check on the power meter in silent mode. Yeah, that's there's a difference. 34 watts in silent mode as compared to 44, 45 in a balanced or normal and high performance. So there isn't too much difference with high performance. It's like 100 megahertz or something. So yeah, I'm actually a bit interested in yeah, we can see that we are cooling off here on the temps in silent mode. Let's see how much of an impact it is running in silent mode. I think that of course in office applications running in silent mode, yeah, sure, why not? It also depends on the display, of course, the battery life then and stuff like that. But if you're doing any kind of production work or productivity work, maybe Photoshop, video editing, gaming, streaming and gaming, I don't know, things like that, then you probably don't run in silent mode unless you want the battery to last for a long flight or something. But yeah, so anyway, I think we should run a test in silent mode. I'll be right back. Right, the numbers are in, and I must say, first of all, I have a sort of a cheat sheet in front of me with some values, so I have to scroll too much here. But conclusion is, now this is maybe only readable to me, but the memory, nothing to talk about. It's within some percentage points of difference between both balanced and high performance mode. Yeah, we can see the CPU tests, like the chess one, no difference, its variance. So maybe these are, depends on which loads are multi-threaded, which are sort of core intensive, which are frequency more intensive, which are RAM intensive, and stuff like that. But yeah, encryption, nothing much to mention. Some scores were even higher than, so it's variance. And the only differences are in the floating point operations. Here we lost like a difference between 60,198 and 46,353. So let's calculate that difference. So we have 60,198 minus 46,353. That's 13,845 points. And that divided by 60,198, 23% slower is the silent mode compared to the high performance mode. So we must remember that we're now calculating percentage points down, so how much the silent mode is slower than the, so they will have a maximum of 100% slowdown instead of calculating speed up, which would be a different figure. So silent mode is yeah, 23% slower. But then we also have some other ones which are also like 5,013 instead of 6,560 or 5,903, and also the ray tracing 32-bit, which dropped a couple of thousand points. So there is a difference, and around 23% is what we saw here. So which seems to be the worst case. The other ones are not as huge, but still the point difference is like a 2,000 points from 12,000 to 10,000, more or less, on the FP32 ray tracing. So yeah, there we have a difference. So that's nice to see. So it means that these settings here do something. Now that we have that settled, let's leave AIDA64 for now, because I can't uninstall things. And oh yeah, when I said that it's out of the box experience, of course I have installed Steam and Intel Driver Assistant. So they're running in the background as well. So there we have it. The Steam, because I got the PC Mark and the 3D Mark from there. So yeah, let's close this and move on to the next type of performance testing. Right, this PC has a Kingston SSD, and however, no version of the Kingston SSD manager manages to find the SSD, so I can't update firmware or anything like that. That would be up to Acer, I suppose, on their website to release some update to the firmware of the Kingston drive or something. But I tried both versions, legacy and newest version of Kingston SSD manager, and it doesn't work. So if we check here, it says Kingston drive. So I've googled it a bit, and yeah, it's a Kingston drive, but it's an OEM drive, I suppose, then, and those usually are not showing up in in the management applications for said devices. So yeah, I will remove the Kingston SSD manager then, and we'll run CrystalDiskMark. Right, we are in high performance mode, and CrystalDiskMark 9.0.1 has just finished. And well, it is a PCIe 4 SSD, but it's only half a terabyte, which is half terrible. I would say in 2025, at least 1 terabyte would be, I think, reasonable for a $1,000 PC. Just my spontaneous thoughts, but anyway, luckily they're not too expensive. But you don't want to buy a device and then start upgrading it from day one unless you know that you are going to do that and you have calculated for it. Then it's okay, you can buy whatever you want and upgrade it to whatever you want, if it's possible to upgrade, which this PC is not regarding RAM. So yeah, but I have I already had a rant about that. So anyway, we got a 4.8 gigabytes per second read and 3.5 gigabytes per second write, sequential. So Q depth 1, 2200 megabytes per second and 2229 respectively. 4K random, Q depth of 3 is 342 megabytes and 348 respectively, and Q depth of 1 at random 4K is 54 megabytes read and 126 megabytes write. These numbers, yeah, the sequentials are okay. I mean, fine. I think you, of course, once again, like, regarding the RAM, then, if we know that we have only 16 gigabytes, sorry, if we know that we only have 16 gigabytes of RAM and we can't upgrade it, right? So if you are the Acer PC maker, you would at least put in a drive of high capacity and high speeds then, because a lot of swapping will be done when it's not possible to fit everything in the RAM. It will have to swap it in and out of the disk. So you want as fast of an SSD as possible and as durable as possible. And to get many terabytes written tolerance or mean time to failure, so to speak, you want a high capacity drive, because you can usually write a lot more data to, let's say, a 2 terabyte drive before it fails than to a half a terabyte drive before it fails, because you have more memory cells. So I think that Acer has done a bit of cutting too many corners without cutting the price enough kind of story, which we see every so often in our lives nowadays. But I think the combination of 16 gigs of RAM and a half a terabyte drive, which isn't the fastest on the market either, I would say half a terabyte is too small anyway if you're gonna do any kind of production. Oops, I restarted this. Anyway, so I haven't really installed much yet. It's out of the box, plus some drivers and Intel driver and assistant, CrystalDiskMark, Steam, 3DMark, PCMark, and AIDA64. We have 365 gigabytes free of 475. Let's say you install Visual Studio, SQL Server, Office suites. I think the Office suite was maybe included here, but you install some applications, Blender, Handbrake, Clipchamp, and you have, if you're editing some videos, you will transfer videos from your phone. Those are maybe 30, 40, 50 gigabytes for a video if you're doing feature length videos like I am, and you will eat up this space pretty fast. And also remember, on SSDs, for trim commands to work properly, you shouldn't fill it up more than 85% of its capacity, because then you will get a very, very slow drive when the trim command can't work optimally. So you don't have even 475 gigabytes if you're gonna keep your performance and the PC usable sort of for those types of applications. You maybe have 400 you can fill up to, or 375 or something. So yeah, very, very greedy of Acer. Almost said Asus, but I suppose, yeah, Acer in this case. $1,000 PC, OLED display or not, a half a terabyte is not acceptable. It just isn't. You can't use it for anything except for, using this as a $1,000 typewriter. And let's be honest, you're not buying a $1,000 typewriter. And yeah, AI PC and stuff, but yeah, not only is the RAM low, but the disk is small. But okay, disk can be bought for $100 at 1 terabyte, or under $200 for 2 terabytes. So fine, it's a $1,200 PC, and I have 2 terabytes of drive, which will, if I buy a fast one, it will be able to swap faster to it. It has more terabytes written sort of lifespan, so it may handle it better. The onslaught of too little RAM and too much swapping. So yeah. But yeah, half a terabyte is not okay, Acer. It's not. It's just not okay. Well, that was that rant. Now let's get on with our lives. So I will actually do the AIDA64 thing, and with the GPU, just to see what happens then. So we will let it adjust the timeout timer, and we'll restart the PC and we'll see what happens. So give me one moment, please. Actually, AIDA64 didn't ask me this time about adjusting the timeout value for the GPU, which I have also checked now, and I'm running the test here. So but yeah, it seems to work fine so far, and the power draw now is at 55 watts or so instead of 45 watts, so 10 watts more with the stress GPU option chosen here. Oh, I should say, yeah, the display here is not it's not touch, of course, even though it's not a matte display, but it's not touch sensitive. So let's have a look at the stats here. Yeah, we have even in high performance mode, we have lower clocks with the GPU option set, and so far the temps are okay. We're below 70. We did hit 71, but that was before the fans ramped up. So we can see that here we got this little bump here in the beginning, and then the fans ramped up and the temperatures went down. So yeah, but about 10 watt difference. So 55 watts or so, and I think the power brick is rated at 65 watts. So we're starting to push our luck on the power brick a bit as well. But of course, the scenarios where you're stressing all parts of CPU with both and memory and GPU at 100% utilization, those situations are rare. Of course, a PC should handle all kinds of loads. You can't sell a PC saying it only handles when the CPU is at a max 50% utilization and GPU at 30%. But anyway, I think that you will get better performance in most applications than when loading the entire system to max, sort of. So yeah, but we'll stop it there. And yeah, let's move on to other types of testing. And I'm thinking PCMark is a natural migration from AIDA64. It tests office type application, productivity applications, and it will be very interesting to see how that goes. And then we'll do 3DMark. Once again, this PC is not a gaming PC. I think the GPU is very capable in itself, but it's still an iGPU, so it's an integrated solution. And well, we won't hit 60 FPS sort of in 1080p, I think, in most titles, especially on decent graphics settings. So with that said, of course, something like playing The Sims or SimCity or something like that, city builders, where you don't need a lot of FPS, might be just fine, I think. But we will see all of that in a little while, because now it's time for PCMark, I think. But before we continue with PCMark, I think it's time to end this part 2 here. So join me in part 3, where we will start with PCMark and later on 3DMark in the coming days. So be on the lookout for that. In the meantime, thank you everyone so much for watching. Have a nice day. Bye bye.